All right, a little bit of converting with the definition of a mole. It asks us, how many moles would you have of potassium if you have 2.4 times 10 to the 24th atoms of potassium? 2.4 times 10 to the 24th atoms of potassium times, it asks me for moles. That's what I'm looking for, moles. It would go on top. And atoms would need to go on the bottom. And the definition of a mole is that it is 6.02 times 10 to the 23rd particles, of which atoms is a type of particle. So we get 2.4 times 10 to the 24th divided by 6.02 times 10 to the 23rd. And if I want to make that math easier on myself, I could relocate one of these 10s and it would be 24 divided by 6.02 times 10 to the 23rd, 24 times 10 to the 23rd. That's not proper scientific notation, but it makes the math easier because then my 10 to the 23rds divide away. And I am left with just 24 divided by 6.02, which should be right around 4. I started with 2 significant figures. My answer will be reported to 2 significant figures. 24 divided by 6.02. Typed it in as multiplied by. I get 3.9867. To round that to 2 significant figures, I want to chop it 3.9. The next digit is an 8. That would round the 9 up. We end up with 4.0 moles of potassium. Then flip it around. It gives us moles of nickel this time, and it wants us to convert that to number of atoms. 0.020 moles of nickel times, and this time I start with moles, so I want to get rid of that. For every 1 mole, you would have 6.02 times 10 to the 23rd atoms. Moles divides away, and I'll be left with just atoms. 0.02 times 6.02 times 10 to the 23rd gives me, my calculator says 1.204 times 10 to the 22nd. This number back here, not significant, not significant, significant, significant. 2 significant figures. I need to keep this to 2 significant figures. I would report the answer as 1.2 times 10 to the 22nd atoms of nickel.